Okay, now it's exactly 1 o'clock, so we'll start on time. Okay, basically for this class, it's the second lesson on magnets. I think you have been going through magnets quite a fair bit. Okay, so some schools might have done it, some schools might have not. But I think just for the sake of our 2 new students today, basically what we do at 88 Tuition is that we do have a curriculum to follow. So what we do is we will ensure that all topics will be covered before your end of year exam. We cannot cater to just one school because, like I said, all schools do different topics at different time of the year. Okay, so you might have done magnets, your friend might not have in this class, but we basically just follow through our curriculum, and eventually we'll make sure that all the topics that are tested for your P3 and 4 science will be covered before your end of year exam. Okay. Okay, so just to basically just to start, we will I'll show you a video. I know usually I put the video at the end, okay, but just for today, okay, maybe we'll just want to start off with a video first. I thought, to get you excited and get you interested as well. Okay. Right. Okay. So I think that basically summarizes what we went through last week. Of course, the concepts that we learn, we need to know how to apply to the questions. Okay. I think the first question is quite straightforward. Any volunteers? This one is basically not application. This is just testing your knowledge. Which of the following objects can be attracted by a magnet? Yes, Mireng.
Iron ball.
Very good. Well done. Okay, so just a quick recap. School is not cool. Steel, iron, nickel, cobalt, right? So all these are what we consider your magnetic materials. And magnets can attract magnetic materials. Okay, so plastic, of course, is not. Rubber and wood are not as well. Yeah, so steel, iron, nickel, cobalt, magnetic materials, or rather you can remember it easier. The acronym SCOOL is not cool. Okay, it just helps you to remember it easier. Yeah. Any questions with this? Yes, Ariano. Ariano, you have a question? You raise up your hand, or do you accidentally press? No? Okay. If there's nothing, then I will move on to the next question, yeah? Right. Next question, also very simple. Yes, Ariana, you want to do question 2? What's your answer for this?
A.
Very good. Okay, because steel is a magnetic material, as suggested just now. School is not cool. Okay, so I won't write it down again. This is again a knowledge check question. I don't think there's anything to do with application. Okay, but there are application questions when it comes to magnets as well. It can be quite difficult to answer, and you need to be able to apply the knowledge and the concepts, yeah? Okay, this one is quite straightforward as well. Mireille and Ariano has answered, so maybe we give someone else a chance. And object X was attracted to the magnet as shown in the figure below. Object X is made of, Ryan?
Iron.
Very good. Same concept. Okay, it's all about the magnetic material. So iron is a magnetic material, so therefore it can be attracted by the magnet. Yeah? Okay, good. Now let's move on to question 4. In which of the following will the two magnets push each other away? Now, when we talk about pushing each other away, it's basically a repulsion. Okay. So they're basically repelling each other. So if it's a repulsion, it means that the light poles are facing each other. Okay, so the light poles face each other. In which of these scenarios do we have the light poles facing each other? Yes, Ryan.
A.
Very good. Okay, so if you look at, let's say if you were to highlight all the north poles yellow. Okay, and then maybe the south poles blue. So you notice that the only one that has like the light poles facing each other is actually your option A. Okay, so for it to repel, you need to ensure that the light poles are facing each other. So the answer is A. Light poles repel and light poles attract. I think that's the concept behind this question. Okay, let's move on. Let me just have a look. Most of you managed to get 1 to 4 correct. I think we'll move on to question 5. Okay, that's why I'm going through very quickly. Some of you did your homework, some of you didn't. Okay. I will not name the names, but I noticed that question 5, 2 of you got it wrong. So maybe I want to go through it a bit more. Okay. Janice prepared 4 experimental setups, P, Q, R, and S, each with an electromagnet coiling a wire around the iron nail to attract some paper clips. So basically she set up like a, a rod inside, and then she has like, I don't know, the wire. Okay, and then the batteries. I think batteries, you can use the symbol like that. Okay, she set up an electromagnet, yeah? She used identical batteries, iron nail, wire, and paper clips. And these were the results, okay? Which of the following aims of the experiment has been matched correctly with the setup? So let's say if we are using P and R, this one you really have to look one at a time. So if I were to use P and R, the number of coils is different. The number of batteries used is different. Can we conduct an experiment when there are 2 change variables? Yes or no? When we conduct an experiment, we need to make sure that there's only 1 change variable, right? So in this case, there are 2 change variables. So that means this is not supposed to be the aim because there are 2 change variables. I can't achieve anything. I cannot test anything because the variables are different for both. Okay, so then let's take a look at Q and S, okay? Q and S. Different number of coils, different number of batteries. So same thing, I'm not able to test anything because there are 2 change variables. Okay, now let's try R and S. R and S. Same number of batteries. Maybe this can work because it has a control variable, same variable. The only difference is the coils. So is the aim of this experiment, if let's say we were to use this tool, the aim should be to find out, okay, basically the change variable is the number of coils, right? So it's to find out if the number of batteries. Number of batteries. No, wait, sorry, number of coils. The thing that is changed, right? The thing that is changed is the number of coils. So it's basically to find out if the number of coils would affect the number of paper clips attracted. But over here, it says that it's to find out if the number of batteries, which is wrong, because the number of batteries is the same. So we cannot find out if the number of batteries will affect, right? So then C is wrong. Then of course, if the answer is D, yes, because if let's say we look at P and Q, okay, P and Q have same number of coils, different number of batteries. So the aim is to find out if the number of batteries, because the number of batteries is different, right? So we can find out if 1 or 2 or 3 batteries will make it track more paper clips. So the aim is correct for P and Q. Actually, we can use R and S. It's just that the aim is wrong, okay? But we can use P and Q, and also the aim is correct. It's to find out if the number of batteries will affect the number of paper clips attracted. So this is correct. Answer is D. Yeah? Okay, right. Any questions so far? This question, I think a few of you got it wrong. So I think I just want to go through again. Someone type in the chat, is it? Let me see. May I go toilet? Yes, you may. Go ahead. No questions? If there are no questions, then I'm going to move on. Yes, Calvin, you raise your hand.
I just wanted to answer the question.
The next question, is it? Okay, let me see. Question 6, I think one of you got it wrong. So that means it's still not too bad, I would think. Okay, which part of the magnet can attract the most number of pins?
B.
Very good. Why is it B?
Because it's like the G and Z is like at the north and south point of like the magnet.
Yes, correct. And I think the underlying concept for this question is that the magnetism or the magnetic strength is the strongest at its two poles. Okay, so this is the pole, these are the poles, so therefore the answer is B. Just remember the underlying concept, right? Magnetic strength is greatest at its poles. Okay. Any questions? No questions, I'll move on. Question 7, also one of you got it wrong, the rest of you got it right. For those of you who did your homework, yeah? One of you got it wrong, so let's just go through. Study the diagram. Rachel placed a strong magnet at the side of the glass container. Which of the items in the container will most likely stick to the side where the magnet is located?
Key and marble.
Key and the marble? Is marble made of a magnetic material?
I think so. Some of them I check on Google that they say like marble. There's those kind of marble that are magnetic and can make like a lot of things.
Oh, generally, I think marbles are made of glass. Let me just show you some examples. Okay. There you go. Okay, generally marbles are made of glass.
Why are
Even
they
this
so
kind,
expensive?
yeah, even this kind that looks like metal, they are actually glass marbles. They are just made using like special finishings, but they are basically made of glass. Yeah. Okay. So in this case, we would think that marbles, they are so expensive, I think, because they are quite rare nowadays. I don't know. Yeah, how much?
I have two marbles at home. It was given by my science teacher.
They give it, they charge like 60 pieces for $49. That's almost like maybe 80 cents each, around there. Yeah. Okay. Anyway, so marble is definitely out. Rubber band is definitely out. Okay, because rubber band is of course made of rubber, and rubber is not a magnetic material, right? I would think that the question, I think, is a little bit unclear. I would have made it clearer by putting like an iron and a steel. Okay, generally these are the metals, and I think if you do process of elimination, those that have V and D are definitely out. So your only answer is C, because marble is definitely made of glass, and this one is definitely made of rubber. Okay, so we can eliminate the questions basically, but it could have been clearer if they were to put like exactly what material key and hair clips are made of. But then again, you can just use process of elimination to eliminate the answers that are definitely wrong. Okay. Okay, question 8. Look at the two setups below. When Joyce moved a magnet under materials X and Y in setup A, the iron ball moved in the same direction as the magnet. However, when Joyce moved the same magnet under materials Y and Z in setup B, the iron ball did not move at all. This should be ball, not ball. Okay, so which of the materials is or are non-magnetic? Question
G
8,
is
let me
not
see.
magnetic.
Okay, question 8, all of you got it wrong. Let me see. Okay, when it does not move, right, it tells you that material Y is magnetic. I'll explain why. Okay, why is that so? When the ball is not moving, the material is magnetic because magnetism can attract magnetic material. It can attract it, but magnetism